all materials have properties, and these properties are going to allow us to decide if the material is going to be useful to build with or if it's going to be a material that we should avoid entirely. The properties that we need to know in grade 3 are these 7. We need to know what torsion is. That's when you take something and you twist it. Bending, of course, is when you bend something. Compression is when you take it and you squish it. If you could do that, it's got compression. Tension is when you pull on something and it stretches. Shear, those are scissors, but another name for scissors is shears, because shearing is when you push in opposite directions. So you push up and you push down at the same time. And that's how scissors cut through things, because this top part goes down, the bottom part goes up at the same time, and it pulls the paper in opposite directions and rips the paper. Nice and clean rips. Okay, that's what shearing is. If you can take something and rip it, you've got shear forces. Waterproof, that's when the material doesn't suck up water. The water stays on top of that material, and oftentimes it'll form little bubbles that just kind of sit on top of the material. If the material gets soggy and it sucks up the water and the material turns squishy, kind of like paper when it gets wet, then it's not waterproof. Transparent, that's a grade 2 word. You probably remember it means when light can go through the object so that you can see on the other side. Like windows. Let's look at what properties does an elastic band have. By the way, you need to memorize these properties. You need to be very comfortable using these words. Now, an elastic band, does it have torsion? Can you twist an elastic band? Remember torsion? Yes, you can. You can twist an elastic band, so it's got some torsion. How about bending? Can you bend an elastic band like that? Definitely you can. How about compression? If you held an elastic band, can you squish it? Can you squish it like that? Yep, you can. How about tension? Can you take an elastic band and stretch it? Well, you can see in this picture, this guy's clearly stretching it, so it does have tension forces. Yep. How about shearing? Remember shearing, what it looks like? Can you pull in opposite direction? Can you pull up and down on an elastic band at the same time? Yeah, you can. Is an elastic band waterproof? Like that. Does water turn it soggy? Does water get sucked up into the elastic band, or does it sit on top of it? Yep, it is waterproof. It's rubber. That's why you wear rubber boots, right? Rubber boots don't get soggy inside because they are waterproof. Rubber, in general, is a waterproof material. How about transparent? Can you see through an elastic band?
No! No! No!
How about a brick? Let's take a look at a brick. Does a brick have torsion? Can you take a brick and twist it?
No!
Nope, you can't. How about tension? Can you take a brick and stretch it?
No!
You heard the man say it. No, you can't. How about bending? Can you take a brick and bend it?
No!
Oh, so far everything's a no. How about shear? Remember what shear was? You pull up and down at the same time. Can you do that to a brick?
No!
I mean, you could. Just the brick won't move, though. It'll just stay where it is. It won't bend or anything when you do that. How about compression? Can you take a brick and squish it?
No!
How about waterproof? Is a brick waterproof? So if you put water on a brick, the water sits on top of the brick. It doesn't get absorbed into the brick. It doesn't make the brick turn soggy. If it did, think about it. If it did, all of those houses in the world that are made of bricks, what would happen to them? Yep. How about transparent?
No!
No, of course a brick is not transparent. You can't see through a brick. Unless you're Superman. How about a hockey stick? What properties would you want a hockey stick to have? Now, look at this here. Now, a lot of people don't know this, but if you take the current hockey sticks that are made of carbon fiber material, they bend. They bend a lot. When you shoot with them, it looks like this. This is Steve Stamkos taking a slap shot. Let's think about this now for a second. Does a hockey stick have torsion? Can you take a hockey stick and twist it?
No!
No, you can't twist it. Can you pull on it? Can you stretch it with tension? Can you hold it on each end and really stretch it?
No!
Can you bend it? Yeah, you can. See? You can bend it. How about shear forces? Can you take it and pull it in opposite directions?
No!
Not really. How about compression? Can you take it and squish a hockey stick? Can you hold it and really squish it together? You know what? Now, why is that? Because we all know if you hold a hockey stick, you can't squish it. So why did that buzzer go off? Here's the reason. Anytime you bend something, look what happens. Do this to your hand. Take your hand. I want you to pull your fingers back. You see how the top part here wrinkles? That means this is getting squished. But if you look at the bottom of the hand, look at the bottom of your hand when you do this. It gets stretched. Anytime you bend something, which is what the stick is doing, part of it is going to squish and part of it is going to stretch. This part here is kind of like your hand over here. It gets squished. This part gets squished. And another word for squished is compress. Okay, so this part of the stick here on this side is getting compressed, kind of like your hand getting wrinkled. But the other side is getting stretched. So this is tension. That's tension. It's getting stretched. Whenever you stretch something, that's called tension. So yeah, it is bending, as you can see. So one part has to get compressed and the other side has to be stretched or tension. How about waterproof? Is a stick waterproof? It better be waterproof because that ice is going to start to melt. And if it melts on the stick and it's not waterproof, you know how that stick's going to start to feel. Kind of slimy and squishy. Is a stick transparent?
No! No!